In the deep ocean, vision is a luxury. Light disappears. Distances collapse into black. So the sea doesn't belong to the one who sees first, it belongs to the one who hears first. Because underwater, sound is everything. It moves farther than light. It wraps around mountains. It slips through darkness like a rumor that never dies. And that creates a strange rule of survival. In the ocean, listening can be safer than looking. Today, we're going to enter the quietest battlefield on Earth. Not with explosions, but with patience. Because the most important maneuver in submarine warfare doesn't start with a weapon. It starts with geometry and a blind spot. Passive sonar means a submarine is not sending out a signal. It's simply listening for whatever the ocean gives away. Example: if a distant ship's engine produces a steady hum, passive sonar can detect it without revealing your position. That without revealing part is the key, because the moment you transmit sound, you create a beacon. You don't just illuminate the ocean, you illuminate yourself. So modern submarines prefer the oldest, simplest advantage: stay quiet and let others speak. But here's the twist: the ocean is never silent. It is loud in a way most people never imagine. Ambient noise is the ocean's constant background. It includes waves, wind, rain, distant storms. It includes ships, fishing boats, cargo routes. It includes marine life, and yes, even tiny creatures. In some waters, snapping shrimp can create a crackling sound field so intense it masks larger targets. Not because shrimp are powerful, but because there are millions of them. So passive sonar isn't like hearing a single voice in a quiet room. It's like hearing a whisper inside a stadium. That's why submarines don't rely on one microphone. They rely on arrays. A sonar array is multiple listening sensors distributed across space. The point is simple. If sound reaches each sensor at a slightly different time, you can use those differences to estimate direction. Example: if a propeller's tone arrives first at the left side of the array, the target is likely left of your bow. This is where submarine listening becomes less like hearing and more like computation. Because the submarine isn't just detecting sound, it is separating sound, filtering it, comparing it, stacking it against patterns. And the most important trick in that process is a concept that sounds technical but behaves like magic: beamforming. Beamforming is the method of combining signals from many sensors to focus listening toward a specific direction. It's like turning your ears into a zoom lens. Example: by steering the listening beam, you can suppress noise from one side and enhance sound coming from another. That changes everything. Because now the submarine can point its hearing at a slice of ocean and treat the rest as background. This is how you find a target that doesn't want to be found. But what exactly are you listening for? The ocean doesn't label sounds with names. It doesn't say, "This is a ship," "This is a submarine," "This is safe." Instead, the ocean gives you two kinds of clues: broad clues and narrow clues. Narrowband sound shows up as thin lines in a spectrogram, steady tones caused by rotating machinery. Example: a pump rotating at a constant speed may create a stable tonal line at a specific frequency. Broadband sound is spread out: turbulence, flow noise, and general whoosh. Example: a fast-moving hull can create broadband noise that rises across many frequencies. Narrowband can be more identifying. Broadband can be more revealing about speed and movement. Together, they form something navies care about, like fingerprints: an acoustic signature. An acoustic signature is the unique pattern of tones and noise a platform produces, from engines, pumps, propellers, and flow. Example: two ships may have similar size, but different tonal patterns because their machinery and rotation rates differ. This is how identification happens in the dark. A trained sonar operator doesn't see a submarine. They see a pattern, a set of lines, a relationship between frequencies, a rhythm. And this is where the silent ocean becomes psychologically intense. Because much of the time, you don't get certainty, you get probability. You get possible contact, likely merchant, maybe submarine, and maybe is the most dangerous word in the ocean. Now we reach the core of this episode, the blind spot. Submarines have something called baffles. It's one of the most famous concepts in undersea tactics, and it's deceptively simple. Baffles are the area directly behind a submarine where its own hull and flow noise reduce sonar effectiveness, a rear sector where detection is harder. Example, a quiet follower positioned behind you can be masked by your own noise. Why does that happen? Because the submarine is moving through water. Water flows along its hull. Machinery vibrates, propellers spin. All of that creates self-noise. And some of the most sensitive sensors are forward-facing, optimized to listen ahead. Behind the submarine, you're listening through the mess you create. That means if another submarine can place itself in your baffles, it can become a shadow. Not invisible, but harder to hear, harder to classify, harder to separate from your own noise. This leads to a chilling idea. A submarine can be hunted without knowing it. So how do submarines reduce this risk? They extend their hearing away from themselves. They tow it behind them. A towed array is a long cable with hydrophones pulled behind the submarine, placing sensors far from the sub's own noise. Example, if your hull noise masks a contact, a towed array can still hear it cleanly because it listens from a quieter point in the water. Towed arrays are one of the most important leaps in modern passive sonar, because they do something profound. They move the ears away from the mouth. They let the submarine listen from a distance while staying quiet, and they can be extremely sensitive. But there's a trade. A towed array is long, it's delicate, it limits sharp maneuvers, it punishes sudden speed changes, which brings us to the most counterintuitive part of submarine warfare. Sometimes the best move is doing less, because speed is loud, and in the silent ocean, speed can betray you. One of the most famous noise sources is cavitation. Cavitation happens when low pressure near a propeller forms bubbles that collapse violently, creating loud noise. Example, at higher speed, a propeller may cavitate, turning a quiet submarine into an acoustic flare. Cavitation is not just a small effect. It can be a catastrophic change in detectability. A submarine that is extremely difficult to hear at one speed may become dramatically easier to detect if it pushes too hard. So, submarines live by discipline, smooth speed changes, quiet machinery management, control of flow noise. And when a submarine tries to follow another into its baffles, it becomes a game of patience. You want to stay close enough to track, but far enough to stay quiet, stable enough to keep your array working, careful enough not to slip out of position. And now you see the real structure of the deep ocean fight. It's not a chase like a car chase. It's a slow problem of angles and sound. Two shadows measuring each other in a medium that carries whispers for miles. But even with arrays, beamforming, signatures, and experience, the ocean is still the ocean. It changes. Temperature layers bend sound. Surface conditions raise noise. Shipping lanes flood the band with interference. A perfect signature can be masked. A false signature can appear. And the hardest part is this. You can't pause the ocean to check. Everything is time-sensitive. Everything is incomplete. Which means the most advanced sonar systems in the world still depend on something ancient. A human being listening and deciding. Long watches. Tiny differences. A change in a tonal line. A faint broadband rise that suggests speed. The silent ocean is less about force and more about restraint. It's about controlling what you emit and extracting meaning from what others cannot hide. So here's the philosophical truth of this episode. Silence is not emptiness. Silence is strategy. When you are quiet, you aren't doing nothing. You are shaping the information landscape. You are choosing what the ocean knows about you, and you are betting that the smallest sound someone else makes, a pump, a prop, a careless burst of speed, will travel far enough for you to hear it first. Because underwater, the winner isn't the one with the loudest voice. It's the one who can survive by being heard the least. And in the next episode, we'll go deeper into how submarines hide inside the ocean itself, using layers, geography, and sound bending as camouflage. Not just silence, but the sea as a shield.